welcome back to yet the audience will see in a minute. Cool. Sorry, I started a tiny introduction before YouTube was telling me I was officially streaming. It's probably the beginning of the stream, it's just... Sorry, starting. Welcome back to yet another episode of Writing a Little Interpreter in C++. The little NHB interpreter, as I'm calling it. Yesterday we left off. We were well into doing the type checking. I was probably heading a little... let's think about the wording. Not going as fast as I wanted to because I was thinking about the typing for sort of integer types. So we've got an integer literal, which is currently a string, and we've got to decide whether we want it to go to an int32 or int64 to take part in an expression. I haven't decided yet whether we're going to have implicit casting from int32s to int64s, or whether or not we'll have to be very explicit with our types. That's a discussion for another time. The key thing is that you want to, when you're converting a type, if someone's typed in a number that is, sorry, shower, so hair is annoying. Typed in a number that's too big to fit inside an int32, you want to check it before you go to the bytecode or interpret it, otherwise you get truncation errors. So you want that to, the compiler to say, hey, not good. And obviously, an signed int32 can only have plus or minus 2 billion, and a signed int64 can have many more. I don't know how big the number is actually. Very big. But not so big that you can't type in a number that's well past it, so you still need to check. At the moment, not planning on supporting other integer types. We don't have a float yet. That confusion was starting to annoy me. I was thinking about type checks, but I was also trying to figure out how to type infer, or to infer this type. What I decided to do is pretend int64 doesn't exist at the moment, and get on with a type checker. That means every integer, literal, will go to an int32. I may just then cast it to an int64 and not allow you to create larger than 2 billion in the initial cut. By initial cut I mean when I have it printing out, when I can actually evaluate 10, add 10, or if some ball value equals something. That's what I'm viewing the initial cut as, a prototype, where we can call some functions, we can do some little number calculations, and that's it. And from there we can start refining our code, which is by all accounts a bit of a mess, and deal with the warnings, tidy up code, improve the algorithms for some things, and gradually start to iterate on this. And that's, there's many directions we could take this, but I don't really want to promise anything yet. It may be that in a week, month's time, I get a little bit bored and the pace of development slows down, and I just decide to stream some game dev or something. That's about it. I'm going to keep focusing on this for the coming till the end of February, so I expect many more streams that not many people watch. And then come March, I'm going to sit down. I'm actually going to fix up some of the annoying things in Visual Studio C-Line. By fixing up, I mean change some key bindings, get some key bindings that work with Ubuntu, and maybe take a bit more effort to learn a few more of the features. I'm guilty of not having sat down and, exercised C-Line to its fullest, and probably, I'm not sure, after that I will probably dive back into it and see how much we can get done in March, but it may be at a slightly slower pace. I'm pushing myself to try and get something working. Once you've got something working, refining is a simpler process. Kind of the way I like to develop, have something working and just keep iterating on it and improving it. Yeah. The process of improving things by 1%. It's a great way to develop. We don't have any compiler warnings would be another thing. I haven't gone through and sorted those out. Need to do that. Need to... yeah, I'm sure there's 100 different things I need to do, along with all the to-dos in the code. Rather amusingly, as I'm digressing, rather amusingly I checked the stats for the previous video, or yesterday, and my total number of people watching my videos yesterday was -1. So, well done me. Right, let's continue where we left off. Okay, right, we were in check types. And when we hit an integer value, we're now not going to return an integer type. We're going to return an int 32. Oh God, why do you do that, Paul? Excuse me, I am obviously drinking this rather protein drink shake again, and obviously been training. That's my life, seems at the moment. My other half is very busy with university work, and so she's currently in the other room writing a dissertation or some equivalent, and, which gives me loads of time to code, which is great. Bite my nails apparently. Variable lookup. Now, I think somewhere up here we can fill in its type here. That will make everybody happy. To entry equals that. Now, it's been declared. If not that, exit. Now we can do node/type equals. Now down where I was, learn bookmarks ball would be another good thing in, you know what, I'm going to start writing these down because then I will do them. Writing down a list of things I'm going to learn in C-line. Oops. I might, excuse me, I might head back into using the Vim plugin. I do have it slightly set up, which makes some of that stuff a little more obvious. So, where were we? Variable lookup. Guess what? We just return node/ Variable definition. Return C underscore. Variable definitions don't return anything. A function call. Ooh. Now, do we do a proper check? Yes, we do. Parameter. Actually, we should never get to a parameter, should we? Function definition. Sibling. It does seem like I need to call it next rather than sibling. Because I go to type next, so that's indicative that that's the name I should be using. Check types in. The fun one's going to be return because we have to keep track of the current function. We need a stack of them. Now, let's get that one for in a minute. So each statement is fine. I'm thinking we have a we kind of do so. If this is sort of letting us return the last expression, ref type. So what I want to do is check the last expression is either return or returns the correct type. If ref type equals So if we're not equal to the void, and then we have a problem. Return. What way you want it died, don't I? What I'm actually saying is what? Oh dear. Right, so we track the line number down just in case there's an error. How many ways can I write? Type mismatch. Right, and the final thing is, while we're checking these, we need to do lucky we are a function based. We don't allow nested functions, so God, this language is boring, isn't it? When we allow functions inside that, when we allow functions in functions, then we will have to have a stack of them as we track what's going on. But for now, that's pretty cool. Unlike that. Okay, which now makes this guy very easy as well. So we want to auto type equal down here we allow returning of an expression to go to null, but when someone's typed an explicit return, then we need a value. If have a problem. What don't you like about that? Nope. There we go. So if you just do type return, I need a semicolon. If you just type return on its own, it needs to be a void return, as in no expression on it. If that passes only if the return type of the function is a void. Otherwise, the first child needs to be the correct type. No conversions. Now, I mean, you could argue that this is also an error. I wonder if it's even possible. You could call a function that's a void. Yes, it is. So, here we go. Now, if God, there's so many errors on this current function. Type. No. Okay. Return type not equal to return type. Well, this could do a good tidy up. Okay, here we go. Let's review. I'm coming to a return statement. We've got a first child, which means we've got an expression. Let's look at the type of that expression, get that back. If the return type is a void, we don't allow void returns. So if return my function call, my function returns a void, that's a legal statement. even if the function you're in currently is void return type. Move on. If the current function's return type is not equal to the type returned from the expression, it's an error. Okay, now if there was no child, there's no expression. That's only valid if the return type of the current function is void. Otherwise it's an error and we error on it. Void return needs a value. Okay, well, I wasn't expecting it to be quite that complicated, but we did. Right, well. Fair enough. Right, we have exp Yep. C# and saying that. I'm not convinced that's the best thing to do. Now, while is a statement, so it doesn't return anything. So I believe that the next one is a code block. And let's just check in here. Yep, cool. So, don't need to check the type. We will return C underscore void type, and we will, which prevents it being used in return and so on. And we will do what? I don't know what we're going to do. We're just going to do cool. I'll fill in all these while I'm waiting. I'm not waiting, am I? In a code box, I think we're safe. Right, let's see if it builds. Holy moly, it did. One of my favourite sayings, holy moly. I'm not quite sure why. Why is that complaining? I think it's there, they're checking. Maybe I missed something there. But right, if expression easy. Got the same thing going on here, which looks looks an awful lot like expectable. Have we got an expectable? Tidy up face, let's worry about that. Holy moly. Then we have we're saying it's an expression, so we need to make sure the code block returns the type of the last thing. And we've got to check they're the same. Right. Which is fine. That works. So true part equals check types. A little bit of it's an expression, but if it was going to void, would we let us there's going to be some smoothing off to do here. Okay, so imagine we've got something, so at the moment I'm going to say that both the if and the else part have to return the same type, which is great for if we do something like let x equal if I 1000 test 1. What about should fail? should also fail. Most of these aren't in the rush I'm going to write in this next 3 minutes, but I'm writing these, so at the moment we're going to pretend it's only used in expression situations, and then we'll do the others at some point. But we've got them as to-dos, and so we will say if false part dot not equal to, what we have to do to capture some of these is track whether or not we're inside an expression, so whether we're in a coplock or whether we're inside an expression. Coplocks unfortunately can also be inside expressions, so that's definitely going to be a stack as we enter in and out of them. I think, yes, nothing too major to track, but just a little wart on it all. Type mismatch. One of the fun things about doing this at night is exit. Okay, I can see a lot of holes in this at the moment. What I've got to return in there, because return returns a type, but maybe it shouldn't. Return should be a void. It should check everything and then return a void, but then we won't know. Let's work that out. We might get some edge cases and have to figure out return, but that's a bit confusing. We shall see. This is the reason I want to get a very minimal language, literally ints and balls and functions, returns and whiles and ifs in. We can write some code with it, just dummy code, and see how it pulls together. I think lots of holes, none of them are insolvable. I'm writing comments to remind myself. Then, once we've got that working, once we've got something working, we shall write code, as I just said, really get it down so it's working nicely. Remove anything, consider others, remove anything that's obviously verbose and unneeded, and end up hopefully with a very small core little language that's obvious. And from there we can start expanding out extra features like structures. We can make the type system more complicated. We can do type inference if we wanted to. We could do some implicit casting, span the number of types we support, not just structures but strings and all that sort of thing. Pointers obviously of some type. But we need a nice core centre on which to build all of this. Without it, a nice core centre that's also clean code. So extensions and stuff. I don't want to be, at the moment the code is pretty awful. If whatever it is, a few thousand lines I guess, let's find out. Probably not even 1200 lines, but it's awful. It's full of to-dos, it's messy. Once we've got that all going, we can start to have some fun. He says, yeah, we'll just see how it goes, and seeing the EM Scriptum compiler, we could even compile it to the web and have it online to dabble with, write some fun little bits of code. And, but the important thing is we get the mismatches spelled wrong. Get it looking good. Let's get it smooth so it's easy to write. But we don't have to get there straight away. We get something working, then we refine. We refine it until it's nice, then we add a feature, then we refine it. We smooth it off. We take a feature out if it ain't working. My plan. I don't know how far I'm going to get in that. I don't want to commit too much. You know what? I forgot to tell the time when it started. Streaming for 42 minutes. It is now 9:42. So we started at 9:07. About looking at the time because I'm currently addicted to The Expanse as well. So that's probably why this is going a bit slower. I was up quite late last night watching it. I actually fell asleep, which is not a good thing. So I want to enjoy a few more episodes of that tonight. Hopefully by the end of this weekend I shall be finished watching it. Highly recommend it. It's on Amazon Prime. Yeah, I finished the horrible drink, so we can move on to something a bit nicer, which is Redbridge tea again, because it's caffeine free and I drink way too much caffeine at work, so I don't need to add to it in the evening. And where are we? Right. Let's review. That means having a look at the if expression. Come in. If we've got a return type, if the expression is check the type of the expression. If the expression is not a ball, we've got an error. I can move on. Move on to the next code, the first code block, the true part. Check the type of that, which currently means just looking at the code block and evaluating it. I don't know how to write code like that at the moment. We will be able to once we smooth it all off. Once we've checked it, move on. If we've got a else part, we need to make sure they're the same. Now that breaks in many conditions which are described above, but we'll keep it simple for now. And then the final part is the if we don't have a true part, should we return, if we don't have an else part, should we return true or should we return void? If we return void, the problem with not having an else part is it's not complete. If the condition fails, then we would end in a what do we return state. So good to review. But if we return void, then that will not match anything. go. Now you will not need to brake. There we go. Right, the important thing about the code block was we wanted to run on the previous type. So, where are we? I've got a feeling I'm looking for this. Oh. No. It looks quite weird with the lowercase to do. Let's initialize it. Initialize it to void. No checking because they're just statements. We're not interested in each one, we're just interested in the last one which we can return. So it works in an if. The other thing we do is we have to get a document going so we can remember what's in the language. Ideally, it's easy to put in your head. I certainly don't want to create a big language, although these days it's hard to create a small language unless you very much limit the scope, which is, I suppose, what we're doing at the moment. What do you reckon? We might, just might. It's like this actually. So boom. At the moment we just got functions, so they're not really in the need of type checks, but in theory we could have static soon and other things, so let's put that in there. Right, let's have a look down. Got a null with returns, so it's possible that I'm adding some null checks in. I don't need to. We can move that to do now. Ooh, what was that? Right. The if expression we just added. Just return the previous type there. If so. Foobarred. While stat is a statement. Return statement, you see, it does say return statement. I think return statement should return void. I think you do if return, that's a void, isn't it? This will fall out. We might test. we've done the check. We're doing that. Okay. May make some of the things I was questioning. Function call. We've still got to do that. Yeah. The sign. Got to check that as well. Goodness me, we've still got a few to do. Oh, this one's easy. This is actually honestly, if I could just use this editor at work as well, I probably would, just to avoid the mismatching keyboard presses. Annoys me. What is it? Have I got a bit of logic wrong there? It's an and. If that's that, if the type's not void and the return type's this value is never used. Seems to be. So we've got a function call. Okay, now 10 o'clock. Function defs. Losing track. Here he is. Check num params num args. Arguments are the values being sent parameters or formal parameters, the things that are in the function definition and tell us what we accept. Types match for params. Return function. First of all, we have to look up we don't have access to the table. So let's put a current table in there, just for this guy. I suppose technically we should be doing it on the variable lookups, but we do not. because we're going in and out and in and out, we don't necessarily, it's going to be a vector. Apparently we've got some struggling. Apparently I'm offline. Stream is healthy. I have no idea. Looking like I have just dropped my stream. Who knows? It's annoying. Where are we? I'll be really annoyed if it's dropped, but let's find out. Come on, you. It still says you're going up. Okay. I've got no idea whether we're still streaming or not. Given I'll give myself a wave and see if that comes through. Hello! We still appear to be live. Says I'm streaming. I'm watching the little corner of me waiting for me to wave. Oh god. Lighting changes so much. Yep, seem to be streaming, but YouTube's decided I'm not. I'm going to leave, I reckon, it where we are. Tabs. Node, color function, tabs. The module is where I don't want to go too far because I've got to think the streaming is probably my internet's about to die off, but what I'm doing at the moment is pushing symbol tables on and popping them off. So that a bit cheeky, I avoided it for the symbol table lookup. Then we go through and we add it in. It starts approaching the point where there's enough shared context that I either need to make a structure of them, or I need to accept that they're a shared context and make a class. I often start with recursive algorithms. Well, that's not good. Control-V, kind of, am I typing it? Now, here we should just be able to do that. And maybe that will work, but I'm not convinced. Well, that should be const because we're not going to alter it at this point. We will alter the state of when we leave tabs with the worth named empty function. Now, if we go to there, he ain't happy about this. That kind of building. Damn you. Actually, you need to be a const there as well. You're looking to get your building. I don't really want to. Okay, let's not add the const in. You don't need to. I'd like to, but I'm not going to. I don't want to get trapped into okay, cool. So what I'm going to say is I'm going to leave it there, working here. Next one, yes, smiley face. We do the type check on the function call. Then we shall. Where are we? Maybe Saturday. Probably won't stream tomorrow because it's wine and pizza night. Well, I haven't been drinking very much, so I'll probably have a small glass of wine and maybe a vegetarian pizza. We shall on Thursday resume. If I don't do anything off stream, then we will. Oh, might be out Saturday. Who knows? Not Thursday. On Saturday we will probably resume, or maybe Sunday. We shall finish off the function call. We shall start writing some code to test and things, just make sure we get any errors out, things are type checking. Get together a bunch of them so we can start running through them, start making a little test framework. Well, a function that runs through a series of functions that work. Then the next step is to start thinking about compiling this down into a bytecode. Bytecode's not going to be low level initially, but I'm going to keep it, as simple as possible. Once we've got that, we can start going through and improving things. Once we've got the bytecode working, which is, I guess we're going to get to that next week. My next focus is going to be on getting some testing. Obviously it's easy to test the positive cases because they work, but at the moment all our negative cases, that's the fails, things that fail to compile, currently exit. We don't want that. We want a little system for logging these errors and then getting out of the code and improving and displaying those errors. That's going to involve messing with the parser again, entering panic modes probably. probably dealing with some errors coming out of the tokenizer as well. I haven't quite got that in my head straight yet. How we're going to do that, but I suspect it's going to be a larger lump as work as all the rest, as writing the bytecode thingy bob we're going to write. From there, who knows? Already 2 stages ahead, and that's probably a good few weeks' work at the rate we're going. That sums it up. Okay, right. I shall call you a night. Thank you for coming along. One watching now, that's me, I suspect. I suppose the other thing, once we hit March, I'm going to start filling out my YouTube about box and all sorts of other fun things. Maybe start linking things back to this so we can do some stuff. Anyway, right, I shall leave it there, and thank you very much.